Hello, students. This video is for you if you are in business and you're either taking Calculus 1 or plan on taking Calculus 1. I'm going to go over some examples that involve some functions in business, in particular demand, cost, revenue, profit. These are wonderful functions you will see in business calculus. I'm not doing any calculus here. We're just going to do some algebra and really pre-calculus type questions that are word problems to get us used to working with these functions. So the first thing I want to talk about is revenue, cost, and profit really as functions of X. X here is the number of items sold. So generally, let's start with revenue. Revenue is the number of items sold times the price per unit or per item. Okay, so let's see an example of this. This is a very simple model, but Rolex charges $6,100 for the Oyster Perpetual 36. Okay, so that is, well, the revenue on X items would be the price, 6,100, times the number of items sold. Therefore, if Rolex sells 50 watches, their revenue is, well, it would be capital R of 50, which is 6,100 times 50. Now, this is a pretty big number, 305,000, so $305,000. We have this revenue of $305,000, but that is not in their pockets at the end of the day because it costs money to make each watch, and we have this cost function, C of X. This is the cost to produce X items. Therefore, the profit, this is what companies are quite interested in, the profit. You take the revenue minus the cost. This would be a company's profit when they make and sell X items. Now, quite often in calculus, or generally, companies, I won't even put the preface in calculus, we often want to maximize profit. And this is something you will learn how to maximize functions in Calculus 1. Now, let's start doing some examples. Tony creates and sells magazines. The cost in dollars of producing X magazines is given by this piecewise defined function. So we have discussed piecewise defined functions in the ramp up. Now, the revenue in dollars for selling X magazines is 5 times X. What is the fixed cost for producing Tony's magazines? And then we have a second part for which values of X between 16 and 50 yield a positive profit for Tony. We can see, just staring at this revenue function, that Tony is charging $5 per magazine. Okay, now this first part for number 1, what is the fixed costs? Well, that would be the cost really to produce 0 magazines. That's just some fixed cost to get started in production. So in terms of this function, we evaluate at 0. Now we've practiced evaluating piecewise defined functions. 0 is in this interval, and so C of 0 is 1/4. 0 plus 2 squared plus 8. You notice this is 4 times 1/4, which is 1, plus 8. So this is $9. Okay, second part. Which values between 16 and 50 yield a positive profit for Tony? Let's write down the profit function. Generally, it's the revenue minus the cost. Now, we have this piecewise defined cost function, but you notice we are only interested in this second interval. So let's write this. For 16 less than or equal to x less than or equal to 50, the profit function is as follows. Well, the revenue is 5x. We subtract off the cost, 2x plus 57. We get 3x minus 57. Let's solve 3x minus 57 greater than 0. Well, I can add 57 to both sides. We have 3x greater than 57, and now just divide by 3. We get x greater than 57 divided by 3 is 19. Really, this is a number of magazines here, so we could either say x greater than 19 or x bigger than or equal to 20. Either one is perfectly fine. Wonderful. My second example has 3 parts. We have an Etsy seller that creates silver bracelets. In order to sell X bracelets, the price per bracelet is given here, 1,000 minus X. Now, the seller has a fixed cost of $3,000 and an additional cost of $20 per bracelet. The first thing we want to do is write down the cost function, revenue function, and profit function. Okay, so let's start with cost. You notice we are given 3,000 as a fixed cost. If you think back to this question, this 3,000 will be my cost function evaluated at 0. But then this part, additional cost of $20 per bracelet. So for example, one bracelet will cost $3,020 if that's all we're producing. If all we're producing is 2 bracelets, $3,040, etc. So we can write this as a linear function, 20x plus 3,000. Okay, so here is my cost function. Now we want revenue, which is the number of items sold times the price per item. We have 1,000x minus x squared, and then the profit we know is the revenue minus the cost. Okay, so the revenue is 1,000x minus x squared, then subtract off the cost. Now, don't forget to distribute this negative sign. So we have minus x squared, we have plus 980x, and then minus 3,000. Here is my profit as a function of x. So we finished number 1. We have profit, we have revenue, and we have cost. Now, we are interested in maximizing profit. As I mentioned, this is something you will learn how to do in Calculus 1. But for today, we will be using a graphing calculator. This profit function is a parabola that opens down. So we will be able to find the maximum through graphing. You have to be careful, though, about your graphing window. Okay, I'm going to use Desmos here. What we're looking at here is exactly our profit function, capital P of X. Now, what we want here is this maximum. You see it is at the point, I'll grab this, 490, comma, P of 490. And let's label it. Here's our maximum. So I'm going to take a screenshot of this and include it on my iPad. We want to locate the maximum profit. That's the Y value, and the number of bracelets that should be sold. That's the X value. Okay, so the number of bracelets that should be sold in order to attain our maximum would be x equals 490. The maximum profit is y equals 237,100. So this is number 2. Now, number 3, what price should be charged to earn the maximum profit? Well, here is the price. So the price is little p, little p of 490, which is 1,000 minus 490. So we should charge $510. Next example, a skincare company finds there's a linear relationship between the number of jars of face cream, X, it can sell, and the price P, it can charge per jar. Data shows the company sells 1,000 jars when the price is $30 each. The company sells 3,000 jars when the price is $20 each. And we want to write a linear equation. P is mx plus b. That gives the price the skincare company can charge to sell X jars of face cream. Well, really we're thinking about this as being a point on the line. This would be the point. The X is 1,000. And then the y, which we're calling p, is 30. This would be a point on the line, 3,022. So the first thing we can do is find the slope of the line. We have y2 minus y1 divided by x2 minus x1. We get minus 8 over 2,000, which is negative 1 divided by 250. Here's my slope, and then you can really use either point. So initially I'll write it this way, y minus 30, except y should be p minus 30 equals negative 1 over 250 times x minus 1,000. Well, this is in point slope form, and you can see we want to write this in slope intercept form. So when I distribute this out, I'm going to have, maybe I'll do it in 2 steps. P minus 30 equals negative 1 over 250 x plus, well, 1,000 divided by 250 is 4. Now, maybe I'll do my final answer in black. We can add 30 to both sides. Here's my final answer. This linear relationship between the number of jars of face cream the skincare company can sell and the price it can charge per jar. Now, for this example, let's do something a little bit different. Let's write the number of jars of face cream sold as a function of the price per item. That is, we will solve for X in terms of P. Okay, well, you notice we have negative 1 over 250. X equals, we can just subtract 34 from both sides. So we have P minus 34. Now we can solve for X just by multiplying both sides of the equation by negative 250. So negative 250 P plus 34 times 250, which is 8,500. All right, let's think about this for a moment. what this gives us is, given a price, we know we can sell X number of jars of face cream. So given a price, we will be able to sell this many minus 250p plus 8,500 jars. There's a name for this in business. This is called demand. Definition: the number, D of P, of items sold at a fixed price P is called demand. So demand is a function of price. Okay, very nice. Let's do an example. But before I start this example, let me change. All right, let's read the question. The demand for a Red Sox Hawaiian shirt fits the model. D of P is P squared minus 600P plus 9,000. What this says is, for a given price, well, between $0 and $300, the number of Red Sox Hawaiian shirts sold will be D of P. Now, this is fictitious, but I like this question because in particular, it gives me an excuse to wear my Red Sox Hawaiian shirt. Okay, well, we have two questions. According to the model, how many shirts are sold when the price is $20? Well, that would be D of 20. This would be 20 squared minus 600 times 20 plus 90,000. You might use a calculator. 78,400. And this is shirts. This is not dollars. The question was, how many shirts will you sell when the price is $20? Okay. Next question. At what price will no one buy a Red Sox Hawaiian shirt? Well, that would say the demand is 0. So we can set 0 to be P squared minus 600P plus 90,000. Okay, you really have two choices here. You could use the quadratic formula. You can also try to factor. What I observe looking at this, minus 300 times minus 300 gives us 90,000. Moreover, minus 300 plus minus 300 gives us this. So we have factored correctly. Well, we have one solution here, which is when the price is 300. And this one is in dollars. So if the Red Sox wanted to charge $300 for this beautiful shirt, no one would buy it, at least according to this model. All right, one more question, and I suppose I will remain in my Hawaiian shirt. The company Just for Cooks estimates that the demand for their designer butcher knives is given by this function. Here we're thinking about the price being between 1 and 4. This is in hundreds of dollars. Find a formula for the revenue generated by selling knives at $100. And then what is the revenue when the selling price is $300? Well, let's go back to the very first page. We were talking about revenue as a function of X. Here I'm going to think about revenue as a function of price, which is perfectly fine. It's still the case that revenue is the number of items sold times the price per unit. So this is the number of items sold. Let's write it down. The revenue as a function of the price will be the number of items sold minus P cubed plus 4P squared minus P plus 10 times the price per unit, which is P. Okay, so we can write it as minus P to the 4th plus 4P cubed minus P squared plus 10P. Okay, This is number 1. Number 2, what is the revenue? When the selling price is $300, we want to evaluate the revenue, but we do not want R of 300. We have to think about units here. We want R of 3. So this will be, well, 3 to the 4th is 81. So minus 81 plus 4 times 27 minus 9 plus 30. We get 48. Therefore, the answer, remember this is in hundreds of dollars, the answer is $4,800. So this is number 2. Here was number 1. Well, we did several examples of functions involving cost, profit, revenue, and demand. And I hope these were helpful for you. Thank you so much.